All right, today we're talking about absolute value inequalities. To be more specific, we're talking about compound inequalities. Okay? Now, in order to solve an absolute value inequality, you need to actually know what a compound inequality is. So let's talk about that first. A compound inequality, there's two different types. There are what we call and statements, and there are what we call or statements. An and statement would be a problem like this. Okay, and the way you say that is you always start with the middle. You say 3x plus 6 is greater than 9 and less than 15. And the way you would solve it would be just like you would solve a problem if it said this. If it said 3x plus 6 is less than 15, you would just subtract 6 and divide by 3. And if it were to say this, you would do the same thing. Subtract 6, divide by 3. And so let's do that. Let's solve. So if I were to subtract 6 on all three parts, okay, you get 3 less than 3x, less than 9. Divide by 3, I get 1. So my solution would be x is greater than 1 and less than 3. Now an or statement looks more like this. It simply says x minus 3 is greater than 1, or it actually has the word or in it. X plus 2 is less than 1. Or statements always have the word or in them. You can never write an or statement like that. And so over here you just simply solve both inequalities. X is greater than 4, or x is less than negative 1. Okay, pretty simple. Okay, but that's basically what compound inequalities are. And so, in order to solve absolute value inequalities, you need to come up with you need to change your absolute value inequalities. You're going to change them to compound inequalities. Okay, so in other words, we're going to try and get rid of that absolute value part. Okay, and again, you need to come up with what we call and or an or statement. Okay, which one is it? Well, and statements are pretty simple. As I look at this one right here, okay, this is an and statement right here. How do I know that? Because it says the absolute value of 8x minus 2 is less than or equal to 24. Less than is and. Okay, an easy way to remember it. And so, since it's a less than or an and statement, the way you write it is this. You're going to simply just write 8x minus 2 less than or equal to 24. And then to create that and statement, I'm going to write greater than negative 24 over here. And now I've turned this into an absolute value, or probably I've turned this into a compound inequality. And we're going to go through and solve. So I'm going to add 2. Let's get negative 22 less than or equal to 8x less than or equal to 26. Divide by 8. So here I get negative 22 over 8, or negative 11 over 4, less than or equal to x, less than or equal to 13/4. And there you go. That's all there is to it. If I put the solution sets here, okay, that's how you solve an absolute value inequality that is an and statement. Less than is and. Now over here, you'll notice that we don't have the absolute value all by itself. So the very first thing is I'm going to actually subtract 6. So I get an absolute value of 2x plus 4 is greater than 6. Now the way you know this is an or statement because it says greater is or. Greater is or. So the way you do that is you're going to just turn it by writing 2x plus 4 as greater than 6, or, okay, and then what you're going to do is you're just going to do 2x plus 4 is less than negative 6. Okay, and so as you see, it kind of looks like this or statement up here. And I'm going to subtract 4. 2x is greater than 2. Divide by 2, x is greater than 1. Or, subtract 4, 2x is less than negative 10. Divide by 2, x is less than negative 5. So if I were to write it in solution set to be all values of x such that I'm going to put the negative 1 on the left, x is less than negative 5, or x is greater than 1. And there you go. Okay, so solving absolute value inequalities isn't terribly difficult. It's just that you have to determine whether or not they're and or statements. Okay, so let's try this next one here. Okay, so absolute value of 3x minus 2 is less than negative 2. Less than is and. So 3x minus 2 less than negative 2 greater than positive 2. Okay, so you notice though that every time that when we do that, okay, this sign switches. So here I'm going to add 2. Divide by 3, I get 4/3. So x is greater than 4/3 and less than 0. Well, that seems a little funny. That doesn't seem to make too much sense. Let's look at that as a graph. Okay, if x is greater than 4/3, well, let me put this 0 and then 4/3 is over here. This says x is less than 0 and greater than 4/3. Well, is that possible for a number to be less than 0 and bigger than 4/3? No. So this one actually has no solution. Okay, or another way you could write it is with the empty set. Okay, so that's an impossible situation. And if you think about that, okay, an absolute value is never going to be less than a negative number. So right away, if you just kind of thought about the problem, you might have saved yourself a little bit of time, and you could have come up with no solution. Okay, last one. Let's talk about this last one here. All right, so absolute value of x is greater x minus 1. So I'm going to write x is greater than x minus 1, or, okay, x is less than negative x minus 1. Okay, so if I subtract x, 0 greater than negative 1, well, that's true. Or over here I get x less than negative x plus 1. If I add x, x is less than, sorry, that's, should say 2x right there, is less than 1. X is less than a half. Okay, well, let's see. Let's think about this here. So here, in this case, okay, my variables canceled out. Okay, but it's given me a true statement. Okay, 0 is greater than negative 1. So that's actually all real solutions right there. Okay, no matter what you plugged in here, it's always going to be true. Okay, over here, x is less than a half. So if I were to graph this, okay, here's a half, less than a half, so that's this part. And then we have the other part being this. It's everything. So if you remember, or we're always going to just have the parts that are being graphed. So we're including everything that's being graphed. Well, what's being graphed? Well, everything is. So my solution to this one is actually all real numbers. So kind of a funny one right there, but hopefully that makes sense. And that's how you go about solving absolute value inequalities.